the last problem in this section essentially wraps everything up. And so what I would suggest is, if you haven't worked through this problem before watching this video, make sure you work through this problem just to make sure that you can do the computations on your own and then watch it, all right? So that way you can kind of follow along with some practice. But essentially what we have is we have a study regarding the website Rate My Professor to determine whether or not there's an association between the overall average rating of the quality a teacher received and the percent of respondents that indicated that they were hot in quotation marks. And you might, for those of you that might have looked at ratemyprofessor.com, this is no longer a feature, but it used to be a feature on Rate My Professor. And so there's 6 randomly selected ordered pairs of data, and we're going to do basically everything that we did before: define the explanatory and response variable, construct a scatter plot, describe the association, if it's linear, strength and direction. We're going to compute R, we're going to interpret R, we're going to see if it matches up to the scatter plot, we're going to see if there's any lurking variables to kind of describe that, and then finally, we're going to come up with some sort of conjecture regarding the average rating of the teacher. All right, so let's start by going through and seeing if we can define some of the most fundamental components of this. All right, so for part A, we have the explanatory variable, and the explanatory variable is going to be the hot rating. All right, so, or I'm sorry, it should be the other way around, is that we're trying to predict what the level of hotness is based on their rating. All right, so the explanatory variable might be the rating and the response is going to be the percent hot. All right, so, and of course we could flip that around if we really wanted to, but let's just say for this study, we're trying to predict hotness based on the average rating that an instructor receives. All right, let's construct the scatter plot. So this shouldn't be too difficult. And for our scatter plot, notice the data ranges from 1.5 to 4.8, and then from 4 to 53. All right, so it's going to be a pretty wide range on one of the axes. Now this one's easy. We just do 1, 2, 3, 4, 5 for the x-axis for the explanatory variable. So we have 1, 2, 3, 4, 5. And also we're going to go through and have the percent hot. Now let's start with 0 and then go up to 50 or 60 or something like that in increments of 10. So we'll start at 0, 10, 20, 30, 40, 50. I think it goes up to 53. So we could probably have a 60 up here. Right? So this is percent hot. And this is going to be the average rating. Right? And then we're just going to go through, like, draw the dots. So we have a 1.5 and a 4, which is going to be right about here. A 2.8 and a 19. So 2.8, just about 20, maybe right about here, as best as we can. All right, and then we're going to have 3.4 and 28. So here's our 3.4, and then we're just going to go up to maybe 28, which might be right about here. So looking like a really good relationship so far. 4.1 and 31. So 4.1, 31 is right about here maybe. And then we have 4.3 and 45. So 4.3 and 45 might be all the way up. So 4.3 and 45. Right about here. All right, a little bit tough to kind of eyeball, so I apologize. And then finally, we have our 4.8 and 53. So 4.8 is right here, and then 53, maybe right about up here. Okay, so, and these should be single dots, so I do apologize. All right, so if I was to ask somebody to be able to describe the strength, direction, and the association for this, again, the first thing you want to do is you want to start by describing the type of association, right? So this is for part C, not B, C. And so, is the association linear or nonlinear? This one's much easier to discern than the first. This is obviously linear. All right, I don't think anybody would doubt me that. In fact, if you just kind of covered up this point and got rid of it, it would be almost a perfect association. Strength would obviously be strong because it's almost a perfect line. In fact, you could say very strong, although that does go against good writing rules to use the word very. And then finally, if we're taking a look at the direction, it looks like as the rating increases, so does the percent hot, so it would be positive. All right, so hopefully that makes sense for that. Now, if the data is linear, compute R using only the formula. All right, so now this is where it starts to get a little bit tough. All right, so I'm going to move this down, and we might stop the video after we get some of the stuff, just to kind of break up the monotony of this. So we have our X variable, and we have our Y variable. And remember, X in this case is going to be the average rating, so 1.5, 2.8, 3.4, 4.1, 4.3, and 4.8. All right. And then the other thing that we have is we have that percent hot. All right, so that's a nice integer value. So we have 4, 19, 28, 31, 45, and then 53. All right, and then remember our other columns that we have X, Y. So that means we're going to multiply. All right, and I did work these out off to the side, so I'm going to go ahead and fill these in. I would suspect or expect that you guys check these using your calculator, right, just to make sure that you can do this, or if you've already done it. So 53.2, 95.2, 127.1, 193.5, and then finally we have this 254.4. All right, and again, to get XY, we just multiply these two columns together. So X times Y gives us the XY column. Remember, we need an X square column. Right, so our X square column, we're just going to have 2.25. Oops, let me erase that, make it look like a real 2.25. Apologies. And remember, we're just getting this by squaring each of the X values like we did earlier. 7.84, and then 11.56, and then 16.81, 1849 or 18.49, and then finally 2304. Finally, we have Y squared, and that's going to be each of the Y's squared. Right, so that's 4 square, which is 16, 19 square, which is going to be 361, 781, 961, 2025, and 2809. All right, and of course, the last thing that we need to do with this table before we start throwing things into a formula is we need to add up every single one of these columns. How much fun is that? So this is going to be 20.9, 180, and then 729.4, and then we have 79.99, and then a really big number, which is going to be 69.56. All right, one last value we need is n before we start using the formula. N in this case is going to be 6 because there are 1, 2, 3, 4, 5, 6 observations. All right, so we just look in the chart. We can count the number of dots. We can count the number of ordered pairs, however we want to do it. All right, so I'm going to pause the video and we're going to go into another one to finish this out. But hopefully you got these numbers. If you weren't able to get those values, go back, see where you might have made an error, and then try to resolve that before moving on.